Okay, we're going to try the video again here. I'm using a different technique today. And we're going to talk about a rhombus and a square. First of all, I'm going to tell you your geometry joke for the day. What do you call an angle that gets into an accident? The answer is a rectangle. Ha ha ha. Okay, we're going to start with a rhombus. And so what it says, you look at your notes here, rhombus, graph rhombus ABCD, and they give you 4 points. A, B, C, and D. Find the midpoint, slope, and the distance of the diagonals. Now, a rhombus, we're going to graph this here. So we've got -3, 6. I'm going to use some markers, a lot of different colors. If you want to borrow some colored pencils or if you have colored pens, go ahead and use that because we're going to do a lot of labeling in this picture and you want to keep everything clear. So A is -3, 6. B is 7, 6. C is 1, 2. And D is -9, 2. All right, now -9 we have to actually extend our graph a little bit. -9, -2 will approximate right about there. Okay, so D was -9, -2. C was 1, -2. And B was 7, 6. Now I'm going to use a straight edge here to connect this. Okay, so we connect all 4 points. And what you get is a rhombus. Now, what does it mean to be a rhombus? Well, it's a parallelogram. So that means that the opposite sides are parallel. The opposite sides are also congruent, but what makes this different is that in a rhombus, all 4 sides are congruent. So each of them has 1 mark. The opposite angles are going to be congruent. Okay, now we'll label that in a minute. The consecutive angles have to add up to 180, they're supplementary. And the diagonals are going to bisect. Now, with the diagonals, let's go ahead and draw those. We're going to draw AC. And then we'll draw DB. Okay, the diagonals bisect. So that means that these 2 pieces are the same, and then these 2 pieces are also congruent to each other. They're not all the same. This is not a rectangle like we talked about yesterday. Okay, a rhombus is a little bit different. But there is going to be something special about the diagonals. So what we'll do here is we're going to figure this out by looking at slope, midpoint, and distance. Okay, to find the slope of the diagonals, you have 2 ways you can do this. For AC, one way to find slope is to count if you have the picture. Rise over run. Now I'm going to start with point A and I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. So we go down 8, which is negative. And then we're going to run. We go down 8. We're going to run to the right 1, 2, 3, 4. And to the right is positive. -8 divided by 4 reduces to -2/1. Now to find the slope of BD, you can do the exact same thing, okay, except this time I'm going to use the formula. I'm going to use m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. One way to remember this, okay, and I know I've done this before, but you can sing the slope formula to the tune Row, Row Your Boat. M equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So in this case, for BD, we'll say y sub 2 is 6. Yeah, I'll go x1, y1, oh, excuse me, x2, y2, and then x1, y1. So we're going to subtract the y's. 6 minus -2 over, subtract the x's, 7 minus -9. And we get minus minus becomes positive, that's 8, 6 plus 2. 7, that becomes positive, 9 is 16. and we get 1/2. Okay, now notice what happens here. You have negative 2 over 1, and you have positive 1 over 2. Those are opposite reciprocals. Opposite reciprocals, and what that means is that your diagonals are perpendicular. Okay, so one of the big ideas in a rhombus is the diagonals are perpendicular, 90 degrees where they meet. All four angles here are going to be 90. Now, for midpoint, okay, we can do the midpoint formula, which I'll write down here. Midpoint is we add the x's, divide by 2, comma, add the y's, divide by 2. So the midpoint of AC, okay, we'll take AC here, add the x's, negative 3 plus 1 over 2. Okay, and you're adding for midpoint. The y values, 6 plus negative 2 over 2. And then we simplify, come down here, add these up, negative 2 over 2, comma, 6 plus negative 2 is 4 over 2, and what we get is negative 1, comma, 2. That's your midpoint. Now if you do BD, you will get the exact same thing. Okay? If you go through the process, you'll get negative 1, comma, 2. They have the same midpoint. What that tells you is the diagonals bisect. Okay, now we labeled that. We just labeled that here, that these pieces here have to be congruent, and that means that the point in the middle is a midpoint, but we're just showing this process. Okay, the last thing is to look at diagonals. Now yesterday for a rectangle, we discussed the fact that diagonals are congruent. Now it certainly looks that AC is shorter than DB, but let's go ahead and verify it. We'll do the distance formula. Okay, this is good practice here. Distance is square root x2 minus x1 squared plus y2 minus y1 squared. Okay, so let's do distance for AC. So I'm going to subtract the x's. I'll do 1 minus negative 3 squared. And then I'll do negative 2 minus 6 squared. Now minus minus is plus, again, so we get square root. That's 4 squared plus, this is negative 8 squared. Now, when you square this, you get 16. A negative times a negative is always positive. So that's positive 64, you get square root of 80. If you do the distance for the other diagonal, BD, you get the square root of 320. Now those are definitely not congruent. So in a rhombus, what do we know? Let's go ahead and summarize here. The diagonals of a rhombus are, they're perpendicular. We use the symbol perpendicular bisectors. They're perpendicular and they bisect. And actually there's one other thing that we haven't talked about yet. They are also angle bisectors. If you look in your picture, all the triangles are congruent. You have 1 mark, 2 marks, 3 marks. 1, 2, 3, 1, 2, 3. They're all the same. If the triangles are congruent, then you know that the corresponding parts are congruent. For example, these two angles. These two angles. These two, and then these two. Now what happens if you look at angle A, the big angle A, it gets bisected. Both of these are the same, and because the opposite angles are congruent in any parallelogram, including a rhombus, you know that these are the same. So we're going to mark, these are 2 marks, and then these are 1 mark. So you have lots of congruent angles when you have a rhombus. Perpendicular bisectors and angle bisectors. Now let's look at the example here at the bottom. And what I'd like you to do is pause the video right now and see if you can figure this out. The 4x plus 2 is going to this angle here. Alright, so see if you can figure this out and then go ahead and resume the video and we'll see if we agree with our answers. Now I'm going to start this. You can start it anywhere. I'm going to start with the sides. I like to look at the outside first. And we have 7z plus 4. Now in a rhombus, all four sides are congruent. So that means 7z plus 4 equals 18. That's an equation. 7z plus 4 equals 18. We'll go minus 4 minus 4. So 7z equals 14. Divide by 7. Z equals 2. There's our first answer. Now if you want to find the x, 4x plus 2 degrees. That's an angle measure. And that's going towards this angle here at the center. Well, we know the angles, the diagonals are perpendicular. So this has to be 90. So there's our next equation. 4x plus 2 equals 90. In a rhombus, the diagonals are always perpendicular. Always 90 degrees. Okay, so we divide by 4, x equals 22. Now the last thing to find is y. So 4y minus 12 degrees. It's an angle. It's this angle here. Now one thing that we also know about diagonals is that they are angle bisectors. So diagonal AC, if this whole thing is 56, that means each piece is 28. And that means that these pieces at the bottom are also 28. So 4y minus 12 equals 28. So I'll come over here. 4y minus 12 equals 28. And we'll solve it. Plus 12 plus 12. We get 4y equals 40. Divide by 4. And y is equal to 10. Now I'm going to stop the video here and then we'll turn it on to the back.